So when you're just trying to represent a question like this with a single variable, it gets a little trickier. Okay, it's a little easier to represent the situation if you had two variables, but then your math's harder. So it's a trade-off. Okay, so at least if you represent this with one variable, you can do the math, and the math is easier, but it's harder to represent the question. Okay, so I have a little method here, and what we're going to say is we're going to say let x represent the son's current age. Okay, now we're going to create like kind of a little table here. Okay. Ooh, getting low on the Apple Pencil too. Okay, so we're gonna say okay, father and son. Okay, and then 3 years earlier. Okay, and then right now. Does everybody kind of see what we're doing? So now our job is, okay, x is going to represent the son's current age. Okay, and so we're going to try and fill in this table using that variable and then use the words in the sentence to kind of do that. Okay, so here's what we're going to get. So let's look at, so how are we going to represent using the variable x the father's age 3 years earlier? Okay, that's our trick here. So it says here a father is 5 times older than his son. So his son is currently X years old. We don't know what it is, but it's X. And then the father is how many times older than him? It's 5, right? So we're going to say, okay, right off the bat, we're going to say this, the father is 5 times the age of his son. But what box are we in right now? 3 years earlier. So we got to go earlier would mean your current age is whatever it is, 14. 3 years ago would have been what? 11, right? So you got to subtract off the 3. Is everybody okay with that? So that's what goes in that box. Okay. Now we could say, okay, currently, the question tells us, right now, right, that's kind of an easy one. Right now, the father would be 5 times the age. Okay. And then the son, 3 years ago. Well, the son's age right now is X. And same thing, if we subtract off 3 years, we arrive at his age then. Okay, and then obviously right now his age is X. Does anybody have any questions, comments, or concerns? I'm trying to figure out the next step here. Okay. So 3 years ago, here's the other piece of information. So we're going to try, I think we're going to try and create 2 sides of an equal sign here. Okay? Tricky. This is a tricky setup. So it says 8 times, so like 3 years ago, 8 times the son was 8 times younger than the father was. Okay, so it says right off the bat, 3 years ago, so we're going to be dealing in this column. And specifically, we're going to use the piece of information that the father, it's talking about the son. The son, so I'm talking about 3 years ago and the son. So that means this box right here. Is everybody following? Just on right this sentence right here. Is everybody okay? So we're going to talk about x minus 3 because it's talking about 3 years ago. But then it also says that the son was 8 times younger than his father was. I'll let everybody soak that up for a sec. I don't know if that's trying to read the room, but it's hard to do with masks on our face. You soak it up, ask a question if you're stuck on anything, and I'll try to answer it. Okay, all I'm doing is trying to dissect the question as best I can, right? You're trying to do the same thing. Okay, and then any questions? I think the right side might be a little easier. How many times older than the son will the father be 1 year from now? I think on the right side, times younger than the father was. Right. Okay. So just in reading this, it seems to me that this is like an algebraic expression that represents all the information in the question 3 years ago. Is everybody all right? So on the left, it says this is like information on the son on the left, and on the right, it's information on the father. Is everybody okay? 3 years ago. Again, this is the hard part of the question, is being able to model this. The math's not so bad. Okay, but the alternative of using more variables is the math gets harder. And so it might be easier to model a particular question using more variables, but it's harder to solve. Okay, so that's kind of your trade-off. Grade 9 versus grade 10. Okay, so what we're trying to do, we're putting a little bit more thought and effort into the setup using just one variable, but then the math is a lot easier. Okay, does anybody have any questions what's going on here? Okay. Now the name of the game now is, this looks like a question. We're just going to try and solve for x now, if nobody has any questions, right? And so the name of the game is to get x by itself. Okay, and you might have 5 or 6 steps to be able to do that. Okay, that's all right. We're just going to do it one thing at a time. I think when I look back to, like, I don't know, 3 or 3.5 weeks ago, I would have said, when I see something like that, get rid of the brackets. Okay, so I'd say, okay, well, let's get rid of the brackets. We're going to get rid of the brackets by taking this 8 and multiplying it inside the brackets, right? So my next line here is going to be something like 8x minus, what, 8 times 3, it's 24. Okay, and then that's going to equal on the right side our 5x minus 3. Do we have any questions? So all I did is take that 8 that's in front of the bracket and I put it inside the bracket, to everything that's inside that bracket, both the two terms. Right, now this is a classic question from before that I said just organize. Organize is the word I use for get x's on the left and get numbers on the right. Okay, so that's what we're going to do now. So let's just start moving stuff around. I'm going to take 5x away, take 5x away, because that creates a 0 pair. But I also have to deal with the 24, the negative 24 on the left, so I can add 24, add 24. Okay, so now if I rewrite this line, I'm going to have stuff that's just shifted spots, left side versus right side. Okay, and all the x's will be on the left, all numbers will be on the right. Okay, so we're going to get 8x take away 5x is going to equal negative 3 plus 24. Okay, you can do the math on that now. That's like collecting like terms. So 8 take away 5 with an x on it is going to be 3x. Negative 3 plus 24 is going to be 21. Okay, and then just divide both sides by 3. X is going to equal 7. So this is kind of like we get to go back to the word, like the question now, and just start trying to answer the question. So we know right off the bat, we know the son's age. Here, I'll write these therefore statements. Okay. Okay, then we can go back. Okay, well, it asks for how many times older than the son will the father be 1 year from now? Okay, well now we know that in 1 year, so we'll say one more therefore statement here. The son age in 1 year will be 8. Okay. And the last part I'm going to have to put some thought into here for a sec. Oh, sorry. No, I don't. So currently the father's age. That was an easy one. The father's age now would be 5 times 7, which would be 35. Right? That's what our table said. And then this is a little overkill on the therefore statements, but I'm just doing it for everybody's sake, okay? The father's age in 1 year would be 36. Did you have any questions? That's a tough question. Aaron?
You're not done.
Oh, what's the last part?
How many times older than the son will the father be?
Oh, how many times older than the son will the father be 1 year from now? Sorry, one final step. Thank you, Aaron. We have to actually answer. We're going to take our 2 answers here. Let me see if I can highlight these in nice colors. Here's the son's age now. Or sorry, one year from now. Here's the father's age 1 year from now. So to actually answer the final part, thank you to Aaron. How many times older? Well, we're going to take 36 and divide it by 8. That's going to tell us 4.5. Okay, so therefore the father Everybody happy? That's a tough one. That's a tough one. Vincent? Okay. Okay, let's hit. If that's the only question, we'll hit stop there, and then I'll talk. I don't mind talking about the test. Okay, because that's kind of all I have for you today. Well, not for this period, anyway.